We're from the Joys, and you're watching TV Western.
Everyone says that green technology is the wave of the future. Well, first-year engineering students are bringing the future to us as they show off their innovations on green technology. Their designs for alternative energy will inspire you to go green, and TV Westerns got the scoop.
This is the first-year engineering design and innovation course. They're given an open-ended problem statement in November. In this case, it was to design an interactive display for demonstrating a green technology. So we've seen lots of people trying to explain how solar power works, how wind power and wave power work, a lot of things in pollution remediation and biodiesel, alternate fuels, that kind of thing. Well, there are 325 students in the course, divided into 8 studios of approximately 40 each. Each studio contains about 10 teams of 4 students. So I think we have 60 projects today, and about 4 or 5 students per group.
Yep, so what we're doing is we're investigating energy storage devices. So the main energy storage devices nowadays are batteries. So we mainly have 2 battery types that are predominantly used in the in the market. There's the lithium-ion battery, which is great for small, light use, long operations. And the nickel metal hydride battery, which is for high-strain power tools and such like that. Both suffer from small cycle durabilities. Both lose efficiency based on their charging and discharging. So what we tried to look for is a new technology that both encapsulates all of those negatives and turns them into positives, and also is applicable into everyday applications nowadays.
So given that this is supposed to be a green technology project, so some may wonder, why is this green? Well, the main idea is that, for example, you take the lead acid battery that's applied in our everyday cars. Lead is a very toxic chemical. It could kill for example, all the fish in a river if there's 15 parts per million, which is 15 milligrams per liter, which is a very, very, very small concentration. So as per our demonstration, we have a fish tank here with 3 fish in them. There's 2.5 gallons of water there and only 3 fish. Now, if I didn't add, but if I were to add 1 gram of lead into here, all the fish would die. It would obliterate all life in this tank. After doing some math, we calculated that, for example, in the river the size of Thames, you could dump up to 147,000 lead acid batteries in it without causing much trouble. Though that may seem like a really big number right now, given the number of cars that we have in Ontario, and yes, though lead acid batteries are rechargeable, there's always a decrease in efficiency, and you'll always have to get rid of something, and they always have to end up somewhere, and they normally end up in our waters, killing a lot of the fish and a lot of the marine life and a lot of the plants that are in there. With ultracapacitors, there's no toxic chemicals that are being used. It's just 2 parallel plates that are able to hold charge and be able to discharge it when need.
So what we've come up with is the ultracapacitor. And what the ultracapacitor is it's basically a normal, ordinary capacitor that has been scientifically changed into being able to hold thousands of times of more charge than they previously could. So what we've done is we've created 2 demonstrations here to just show generally how the capacitor works and how well it can be applied into normal applications. So we have our car here, this fancy little remote control RC toy. And what we've done is we've fabricated a little holding device to hold 2 ultracapacitors, which we put in series. What these ultracapacitors are able to do is actually match the voltage created by 3 AA batteries, which is what it normally runs on, except that we've now reconfigured the system so that it only runs off of the ultracapacitors. So the way that we charge this up is by using just simple batteries. So we've connected batteries in series here with a simple little resistor, and what we're doing is just applying this circuit across the series of capacitors, and it charges them up. So we've already previously charged this up for you guys, so we can run this and demonstrate it. So it's turned on here. We'll get the controller working. and we get full movement just as a normal battery would. The performance aspects are just the same. I mean, the capacitors don't hold nearly as much charge as a normal battery does, but that's based on the nature of ultracapacitors. The fact that they won't ever be able to match completely what a normal battery can, but it does its job.
Now, someone may ask, what future improvements does the ultracapacitor hold? And in every engineering project and design, there's always a way to improve the design itself. Now, with the ultracapacitor, as stated before, it does hold a very fast discharge rate. If there is a way we can engineer, for instance, the internal resistance to be in a specific range that would slow down the discharge rate, then that itself could make it more relevant into the everyday replacement for batteries.
Okay.
So this is Group 9 saying ultracapacitors,
the search for green performance.
This project is demonstrating the conversion of wave power into electricity. So basically we're using this container here to displace the water. It moves the water up and down. You can't really see it well, but there's a float here. It moves the arm up and down, and you can see there's a light here. Powers the light. You can turn the switch. You can power an electric buzzer. We hooked it up to an oscilloscope in an electric lab. This is a graph of the output here. We get about 1.5 to 2 volts out of it, so it's better than we thought. We calculated the efficiency of the whole system, and it comes out at about 7%, which is pretty impressive because the actual wave power systems out there right now operate around 10% efficiency. So it's pretty important because there's a lot of research being done into wave power right now. So currently it's not being used commercially, but they're developing it, and so it's just important to let people know what's out there because we obviously need to come up with new green technologies to prevent the use of, to reduce our carbon footprint. There's obviously some challenges with the environment. Electrical devices create an electromagnetic field out in the ocean, and that tends to disturb fish patterns. They're having to do some research to fix that right now. There's also a high cost of waterproof parts involved, but there's a lot of research and money being put into improving this right now. So,
well, I don't want to single any out. I don't want to call your attention to any one student more than anybody else, but I did see a lot of projects today that exhibit a lot of innovation and a lot of analytical skill.
Waving at the passing cars,